Let's take a look now at OO programming versus non-OO programming, okay, when it comes to algorithm design. So previously, we started with main. We used stepwise refinement and we determined the processing steps that needed to occur. Straightforward. We looked at what data we needed and therefore what data types, what variables, and what were the structures we needed. Straightforward. Okay, and we were refining things as we went, and it was a repetitive process that we kept doing until we were there ready to code and get going. Okay, now things are done slightly differently when it comes to object-oriented programming. Okay, so we look at classes and we identify the classes that we need. We look at the roles or the responsibilities that each class is going to need assigned to it. What do they do? Okay? And then we design our required methods. And you're thinking, David, we know setters and getters, okay? Accessors and mutators. But sometimes there are more methods that we're going to need. And we will, again, be looking at them as we go, okay? Now we thoroughly test each class with a test harness. And that's not overly complicated. We create a class and then we create a small program, main, that what that does is it will create objects, and then we test each method to ensure it's working as designed. Okay? And then what we do is we design our main algorithm and any more algorithms that are required that make use of and take the classes, the objects we've made, and then starts to do things with it. So where does main go? Okay, so main and some of our other required methods that might not sit within an object, okay, they will have a class of their own. Now this class, all right, is used to drive the construction of the objects as well as the use of the objects and any other classes that we have running, okay? So it becomes, I like to think of it as Zentralstation, Hauptbahnhof, central station, okay? This is where everything starts and then goes out from and comes back to and does all kinds of things, okay? It's what's going to use all of the functionality that the classes provide for us. Let's have a look at a working program. Now make sure when you're doing this that person.java is going to be in the same directory as our personapp.java, okay? Now, we can pass stuff around, so let's have a look at the program. So, public class person app, public static void main, we're familiar with that. We've got our main up and running. And now we say person. Okay, this is our class, remember? Person. In the past, we might have had string there, all right, but not now. We've got person. And now we say player one. This is the name of the object we're creating. We're creating an object called player one of type person. And we say that's going to be assigned new person. And you can see we're using the constructor with parameters. First name, family name, day of birth, month, year. And then all I've done here is I've gone system.out.println player one first name, player one dot get first name open close brackets. So I've called the method on our object and we're going to get the value of first name. And we do that here and here and here. So we create 4 different people. So this one here I've created again with constructor, okay, constructor, of course, constructor with parameters. This one is constructed using the copy constructor, and you'll notice here it's the default constructor. And each time I just printed out one value from the new object, okay? What makes up a class? This is going to sound, and I roll my eyes, and no, it's going to sound a little bit repetitive, but it's crucial that we get into it. Okay, so each class we use to create objects, okay, and it's going to contain certain things, variables, okay, our class fields. These are hidden from the outside world using or defining them as private. They are accessible anywhere in the class, okay? So within, I'll say person. I'm now not writing true Java. Open brackets, close curly brackets. Our class fields, although private, will be accessible anywhere within person class, okay? And they're going to contain the values that determine the state of the object. Now we have a set of publicly accessible methods so that when one object, in this case person object, if something else wants to interact with it, there needs to be a way to interact with it, okay? And that's what we're going to have our accessible methods, okay? And sometimes we have a set of private or hidden methods that only the class can use, okay? So the public methods are usually concerned with initializing, accessing, or modifying our class fields. Roles of the class. Each class should be defined with a specific role in mind, okay? So we should have in mind a specific role this class is going to play, okay? And a software system's total set of functional requirements is broken down into a set of tasks, okay? So we've got this set of tasks that our program needs to do, and we're now going to be having objects working with us. And as we say, tasks grouped together, mapped to roles, roles are mapped to classes. Straightforward, simple stuff, but pretty in-depthly complicated. What does our class specify? Okay, our class is going to specify lots of things, but one of the things it does, it specifies the communication that will occur with the rest of the system, okay? Now, the method of data representation is going to be required. We need to know how this data is represented. Exactly how the required functionality is going to be achieved. These are things that our class is specifying. Now, an object, the instance of the class, okay? We've got the class definition providing us a template for the object. And the object provides for us details for a particular instance, okay? So we start with our class and we break it down. These are what are called model classes, okay? And model classes, they model something from the real world. Static classes, what are they? Now, static classes, what a class can have is it can have a whole collection of related constants and methods. And so we might have a whole lot of just things we want to do, things we want to execute. So we have these static classes, and these static classes have constants and they have methods, and we can call them in other classes for using, okay? A static class. Now, with a static class, we never instantiate that. We never create an object of it. We don't do that because they're static classes. The math class is an excellent example of a static class. We never create an instance of the math class, but what we do is we create other things that then use the math class, and we can perform all kinds of calculations using the math class and methods from the math class, but we don't create an object of it. It is a static class.